The Collagen Theory. The Collagen Theory states that the rate or the speed of the reaction is directly proportional to number of effective collagens so if we have more collagen means faster rate. And why the reaction decreases, why the rate or the speed of a reaction decreases with the passage of the time, that can be explained by Collagen theory. So in the beginning, you have more particles. So as there are more particles of a reactant, more likely they will collide with each other. And this will result in a formation of a greater change in the reactant. But as the reactant particle decreases with the passage of a time, so as the number of the reactant particle decrease, the number of the collagen will also decreases. So in the beginning, more particles, more collagen. And more collagen means faster rate. So this will react fast, like convert into product. In 1 second, more particles of reactant convert into product, but this will be slower because less number of the particles, so less number of collagens, which result in a smaller change in amount of reactant to product. So this is a collagen theory which explains the rate of the reaction depending on the number of the collagen of reactant particles. So as we sketch a graph for amount of reactant and time, so using a graph, how we can find a rate of the reaction? So example, if you have in the question, reactants are given, amount of reactant, and time is there. It can be minutes, it can be seconds, hours, depending on the type of a chemical reaction, if it's very slow or fast. So 2, 4, 6, 8, 10, and 12. It will start with a maximum value. So amount of reactant always decrease with respect to time. So it should start with the maximum value, and with the passage of a time, it will decrease. And eventually it will be horizontal. When it is horizontal, it shows that the reaction stop. Now, if in exam, if a question is find the rate of a rate, because the rate varies. Rate is not constant for a chemical reaction, it's a curve. So it will vary. And if the question is find the rate at time is equals to 4 minutes. So you have to calculate the rate when time is equals to 4. So what you will do, whenever there is a curve, you always draw a tangent to find a specific value. As we know, the slope represent the rate or gradient represent the rate. So what we will do, the first step, we will mark a point where we want to find the rate. So example, we want to find the rate, rate or speed of a reaction when time is equals to 4. So what I will do, I will mark a point where time is equals to 4. That's the first thing. The second thing, we will draw a tangent to the point marked. Length of the tangent, it's up to you. Tangent means a line which only touch the curved surface or another graph line at one point. That's called a tangent. So we'll draw a tangent. The tangent should touch only that point, a specific point. The length of the tangent, it's up to you. So example, I draw this as a tangent. Length, it can be longer, it can be shorter, but you should draw a longer tangent. Why? Because when you draw a longer tangent, your answer is closer to the accurate value. So try to draw a longer tangent like 5 centimeter, depending on the graph as well. But 5 centimeter is enough to get the accurate answer. But length, this length of a tangent, it's up to you. You can draw longer, you can draw shorter tangent. So first we mark a point where we want to find a rate, then we draw the tangent to the point which we mark, and then we will find the gradient of the tangent. What is the formula to find the gradient? The formula to find the gradient is y2 minus y1 over x2 minus x1. So what is y2 and what is y1 and what is x2 and x1? The first point, like tangent will have two ends. Just so this will be the first point, that's y1, the start of the tangent. And how you identify that's a start, because you can see a time axis 2, 4, 6, 8. So this will be the start. So first point on y-axis is y1. The second point on y-axis is called y2. So this one is y1 and y2. And for x-axis, the first point on x-axis is called x1, and the second point on x-axis is called x2. I'm just making to 8, so I will have a whole number, but it's not. It should be a straight line. So this is x1. This one is x2. So we have x1, x2, and we have y1, y2. We have the formula for finding a gradient, which is y2 minus y1 over x2 minus x1. So y2 is 40. Sorry, y2 is 10 minus y1 is 40 divided by x2. x2 is 8 and x1 is 2. So when you solve, this will be minus 30 divided by 6 So this is equals to -5. Now what is the unit of the tangent or a gradient? So unit of the tangent is always the quantity on y-axis divided by quantity on x-axis. So unit on y-axis is gram and unit of x-axis is minute. So it will be 5 grams per minute. What this negative sign shows, it shows that it is decreasing. That's why it is a negative sign. But in your final answer, it is not necessary you mention a negative answer. You just mention 5 gram per minute. So when the time is equals to 4, the rate or the speed of this reaction was 5 grams per minute. Means every minute it was changing 5 grams at specific this point. Is it clear? Finding the rate or the speed of the reaction by drawing a tangent. So first what we did, we mark a point where we want to find the gradient or the rate. Then we draw a tangent. Length of a tangent, it's up to you. Longer tangents will give you more accurate answers as compared to shorter tangents. Then take 2 points of the tangent. The starting point is x1 and y1 and the ending point is x2 and y2. And find the gradient of the tangent. The gradient of the tangent is actually the rate of this chemical reaction. Is it clear? I need a response. If any doubt is there, you can ask. If no question, then we can move on to next. Take the screenshot. Then this is if the reactant, if a change in reactant with respect to time was given, then you can draw a tangent and find the gradient. Another type of a graph, if the amount of product is given, amount of product or volume of the product, say centimeter cube, in time is there in minutes. So volume of a product, in the beginning you have a smaller, no product. When time is equals to 0, amount of product is also 0. But with passage of a time, the amount of product increases and eventually it will be constant. It shows that the reaction stops. If a question is find the rate when time is equals to 6 seconds. So what we will do, we will mark a point where we want to find rate. Then we will draw a tangent through that point. Then after drawing a tangent, we will find gradient of the tangent. So first we mark a point where time is equals to 6 seconds. So this is a point where time is equals to 6 seconds. Then what we'll do, we'll draw a tangent. In this case, we'll draw a tangent up, because if I try to draw a tangent from bottom, the tangent will cut the graph line. The tangent should not cut the graph line. So in this case, I will draw a tangent at the top. Length of a tangent, again, I repeat, it's up to you. You can draw a longer tangent, you can draw a shorter tangent. The first point on y-axis is called y1. On x-axis, it is called x1. So the second point on y-axis is called y2 and x2. So this one is y1, y2, x1, x2. So we'll use the gradient y2 minus y1 over x2 minus x1. And then substitute the values. When you substitute the values, you will get the final answer. Is it clear? I'm not doing the calculation part here. Is it clear? So if it's a product in time, you will sketch, just mark a point and draw the tangent. Then if you want to compare the two reactions, and the question is identify which reaction is faster. This one is reactant, amount of reactant with respect to time. Can you identify which reaction is faster, A or B? Which is faster? Which shows a greater change in amount of reactant with respect to time? So A is faster and B is slower, because A shows a greater change in amount of reactant or greater change in the slope as compared to that of B. Same thing if you have a product and time, and you have two graphs. Which one is faster, A or B? Which one is a fast reaction? Which reaction is fast? Actually, the correct answer is A. B is slower reaction. Because the slope of the reaction, the slope of the reaction shows the rate of the reaction. Means the slope of this graph represents the rate of the reaction. A, on y-axis, you have amount of product. So what happened, like example, you can see the reaction A completed in a short time. Product was increasing, and eventually at this point, there is no change in the product. So it means the reaction stops. So example, it took 4 seconds to complete. But when you check for B, is it less steeper or it take more time to complete the reaction? At this point, it completed. Maybe it completed at 6 seconds. So the one which is steeper is a faster rate of the reaction. So when it is reactant in time, keep in mind when it is amount of reactant in time, the one which is below is faster. But when it is amount of product in time, the one which is above is faster, which shows that the product formed in a short time and the reaction stopped. This is the point where the reaction stopped. The reason why these graphs are important, because they ask to draw or sketch a graph for reaction faster or slower. So if I say in exam, they might likely like they provide one graph and they say sketch a graph. This is a, for example, a volume of react product. Sorry. This is volume of product with respect to time. And the question is sketch a graph which is faster than this. So where I should sketch, it should be steeper. This shows the reaction is faster. You can see when the lines start to be horizontal, it shows the reaction stops. If I say sketch a graph which is slower than this, so it should be less steeper. So this is a slower reaction below and the faster reaction above. So in exam, you will have graphs and you have to sketch the graph. It's not by calculation, it's just a sketch. So if you want to sketch a faster reaction, it should be above, with more like greater slope or much steeper than the graph which is given. And if you want to show a slower rate of a reaction, then it should be less steeper. Is it clear? Then how the rate of the reaction or factors which affects the rate. So the factors which affects the rate is amount or concentration of reactant. Number 2, temperature. Number 3, pressure, only for gases. Pressure only for gaseous reactant. Surface area. Catalyst. And some of the reaction, external factors such as light, it's only for photochemical reaction. Photochemical reaction means reactions which initiate or start due to light. So we'll discuss each factor. rate of reaction. First, the amount or concentration of reactant. The first factor which affects the speed or the rate of reaction is amount or concentration of the reactant. Example, you have A and B are the reactants, and they're forming a product C. You have 5 particles of A and you have 10 particles of So example, you have 5 particles of A and 10 particles of B. Now, when they start to react, how the chemical reactions occur? The chemical reaction occur by collision of the particles. When the particles collide with each other, the chemical reaction occur. So in the beginning, you have more particles. So in the beginning, you will have more collisions. And just to explain the idea, if I say I have 5 grams of A and I have 10 grams of B. So 5 gram of A is reacting with 10 gram of B. The reaction, they collide with each other, the reaction occur. In the beginning, because there are more particles, so more effective collision. That's why the steeper or the faster rate. But with the passage of a time, the number of the particle decreases. Eventually, one of the reactant will be used up completely. So in the beginning, at the start, more reactants, but with passage of time, amount of reactant decrease. Eventually, one of the reactant finish first. Which reactant will finish first here, A or B? Which reactant will be used or finish first come here? So because you have 5 grams of A and 10 grams of B, so definitely A will used up first. So the reactant which used first, that's called a limiting reactant. Limiting reagent, or you can say limiting reactant. So if I sketch a graph for reactant amount of reactant and time, so in the beginning steeper slope, then eventually the slope decreases, eventually there is no change. Eventually there is no change. It shows that so in the beginning the reaction is fast, then the reactions slow down, and at the last the reaction stops. Now what will happen if I use more reactant? If I increase the concentration or if I add more reactant, so means there are more particles. So if there are more particles, what will be the result? For a volume of a product, it will affect two things. Yes, you have a question? So the reactant which used up completely is known as a limiting reactant, and the reactant which is left is known as excess reagent. The reactant which is left simply known as the excess reagent or excess reactant. We are sketching a graph for volume of a product and time. And for factor the concentration, the effect of concentration or amount. On rate. So if we change excess reagent, so I'll give example, say A and B were the reactants and they're forming a product C. So volume of a product C is there. I use 5 grams of A, I use 10 grams of B. So 5 grams of A is reacting with 10 grams of B and forming a product C. And this was a graph. So this was the original graph when 5 grams of A is reacting with 10 grams of B. If I change the excess reagent, like I took the 5 grams of A, this was experiment 1, but in experiment 2, I took 5 grams of A, but instead of taking 10 grams of B, I use 15 grams of B. So what will happen? In this case, the amount of product is same because the amount of product depends on the limiting reagent. I have a limiting reagent 5 in both experiment. The amount of product, because once the A used up, the product will not form. So both cases, we have a limiting reagent A, which is 5 gram, and we change the excess reagent. So if we change the excess reagent, what will happen if we add more excess reagent in a reaction 2? So experiment will be faster, but the amount of the product will be same. The rate will be steeper, but the final product will not change. Why the final product is not changing? Because the final product depends on the limiting reagent. If the limiting reagent is used up completely, like 5 grams of A in experiment 1 and 5 grams of A in experiment 2, that will result in a formation of same amount of product in experiment, both experiments. But what will happen if I change the limiting reagent, like A is reacting with B? First, I use 5 grams of A with 10 grams of B. Then I use 7 grams of A with 10 grams of B. So if I change the limiting reagent, So if we change the limiting reagent means the element or a compound which used up completely. So we increase the amount of limiting reagent. Then what happened? If this was experiment 3, so this was experiment 1, experiment 2. So what we will observe? We'll observe that the rate will increase as well as amount of product will also change. Is it clear, the concept that how the rate of a reaction is affected by the changing the concentration, but it depends on which concentration we are changing, concentration or amount. If we change excess reagent, the rate will change, but amount of product will be constant or same. But if we change a limiting reagent, rate and amount of product both will change. Is it clear, the idea how a rate is affected by the concentration? So example, if I say hydrochloric acid, magnesium react with excess means excess reagent, hydrochloric acid. What will happen? Gives hydrogen. What will happen to rate and amount of hydrogen if more magnesium is used, and B part, if more hydrochloric acid is used. So magnesium is reacting with excess of hydrochloric acid. So hydrochloric acid is excess. So if I change, excess means more than enough. The term excess means more than enough for a reaction, or too much, or it will left behind. So if I change magnesium, so this shows magnesium is a limiting or small quantity in a reaction, and hydrochloric acid is in excess or more than what we need. So if we use more magnesium, what will happen to rate? It will increase the rate, and the product, the amount of hydrogen will also increase. But if we use more hydrochloric acid, the rate will increase, but amount of hydrogen, the product will be same. So the idea is that the rate of the reaction is only for the first, no, rate will affect both cases, the rate will be affected. But amount of a product, if we change a limiting reactant, amount of product will change. So if we